Alright, you're welcome to my channel once again. My name is Mojaro. If it's your first time coming across my video, what I usually do here is bring out some questions, and as I'm trying to bring out the answers to the questions, trying to explain the points in each of the options. So it's not just looking at the questions, but trying to analyze the point in each option. Of course, this question here is very, very easy and very, very simple. Of course, these videos are for those of us that are coming up in chemistry, those of us that are preparing for the UTME exam, and of course the WAEC examination. Quickly, let's jump into the matter at hand very, very fast. Now, there's a question here, and the question is coming from chemical reactions. And this is one aspect of chemistry that is very, very important as you're preparing for the examination. Now, this question is very straightforward and it's very, very simple. But what we're going to be doing is that we're not going to just look at the questions. I want to bring out some points like I usually do in other videos. So if you know this your first time of coming across my video, please do well to look at other video in my channel. Of course, do well to subscribe, and after subscription, do well to also share the video so other persons that are preparing for the same exam get to see it. Now, look at the question. They said a measure of the degree of disorderliness in the chemical system is known as dash. They said enthalpy, they said free energy, they said activation energy, they said entropy, and they said what? Equilibrium. Now, first thing first, the answer is not the problem. We already know the answer. I will reveal the answer to you for those of us that don't know. But I just want us to analyze each of these options in the sense that in case you come across these questions in subsequent examination, you're able to do what? To track it down. Now, look at something. They said a measure of the degree of disorderliness. Now, I want to explain this question like this. Now, we have something like solid. Sorry, if we have what? If we have solid, we have liquid, and we have what? Gas. Remember that these three, they are made of particles, and of course the particles are moving very, very fast in some. So all of them are made of particles. For solid, the particles are restricted. That's why solid do have shake. Now for liquid, the particles are free to move about. Now for gas, the particles are more random, so they can move quite randomly, very, very fast. Now the degree in which these particles move is what is the disorderliness. So the particles in gas are way more disordered than the particles in what? In liquid. And the particles in liquid are way more disordered than the particles in what? In solid. So the degree of disorderliness or randomness of a chemical system is what is regarded as what? As entropy. So usually call it, so if I say entropy, and this entropy is represented with what? With x. So if I now say delta x, that means I'm referring to what? To entropy change. So the degree of disorderliness or randomness of a chemical system of a molecule is known as what? Entropy. So if they give me something like this, for instance, maybe they say they said water, they said water, for instance, they said water, they said steam, and they said ice. Now they will ask us in the exam which one of them we have the highest entropy value. The one that we have the highest entropy value is the steam, in the sense that the steam is form of vapor or gas, so it moves easily randomly. Which one we have the lowest entropy value is the ice, followed by the what? That of water. Now remember, put it at the back of your mind. Entropy is the degree of disorderliness or what? Or randomness of a system, and it's represented with what? With x. So if I now say delta x, I want to calculate for delta x. Most time in our examination we ask to calculate for delta x. You put this formula at the back of your mind. Delta x is equals to what? Delta h, which is taken to option A, over what? Over t. Now the t here actually stands for what? Actually stands for temperature. Why the delta h stands for what? For enthalpy change. Now what is this enthalpy? This enthalpy means the heat content of a chemical reaction. So you can simply say the heat content of a chemical reaction is known as what? Enthalpy. So, and it's represented with what? With H. So if I now say delta H, I'm referring to what? Enthalpy change or heat change, which can be gotten by what? By heat of product minus heat of what? Of reactant. That means those heats that are found in the product or generated in product and heat in the reactant. Now, quickly, if delta H is positive in a chemical reaction, is signifying something. Now, I'm trying to draw the point very, very fast to make sure that the videos are very, very short. Now, look at it. Delta H, if delta H is positive, for example, they write an equation, they said A plus B to give me what? C plus D. At the end of 10, let's say delta H is equals to plus 300 kilojoule per move. For instance, now they give you this value and you're seeing that delta H here is what? Is positive. What that simply means is that the reaction is said to be what? Is said to be an endothermic reaction. So any reaction that delta H is positive is known as endothermic. First of all, we have known already what's delta H. What's delta H? Delta H is enthalpy change. What is enthalpy? Heat content of a chemical what? Reaction. So if delta H is positive, that means that reaction is said to be an endothermic reaction. And what are endothermic reactions? These are reactions in which heat is what is absorbed from its surrounding. So those reactions that absorbs heat, they are known as endothermic reaction. Now, there are some reactions also that liberate heat. And what we call those reactions? Those reactions are known as what? Exothermic reaction. Now, for me to know that a reaction is exothermic, delta H is what? Is negative. So for exothermic reaction, delta H is what? Negative. So when delta H is negative, it simply means that the reaction is said to be what? Exothermic. So for example, that I write this equation and I put minus 200 kilojoule per mole or 300, it simply means that that reaction is what? An exothermic reaction, that heat has been liberated up to the surrounding. But if it's positive, it's an endothermic reaction. That means heat has been what? Absorbed. Now, if we have said that, what's now free energy? They usually call it Gibbs free energy. Look at it. They usually call it what? Gibbs free energy. Now, what's this? This is the energy that is available to perform work in a chemical system, and it's represented with what? With G. So if I now say delta G, I will now say delta G is what? Gibbs free energy change. You're getting the picture now. Therefore, if what will I use? What can I use to calculate delta G? Delta G is equals to delta H minus T delta what? X. Now, please remember these formulas. They are very, 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 very what? Important. Now, we are putting our answer already to the question. The answer here is what? Is C. But we're trying to analyze each of the options in case you come across them in the examination. You know how to do what? To approach them slow and steady. Now look at it. You already know what's delta S, which is entropy change. Of course, you know entropy change equals to delta H over T. This delta H is what? Is enthalpy change over T, which is what? The temperature. Now we are going forward to the what's free energy change. Says the energy available to do what? To perform work in a chemical what? System. Now quickly, let's continue what we're saying. So this is the formula to calculate for what? For delta G. Please, I want us to pay attention to this. If in a chemical reaction, delta G is equals to 0, this one you have to be mindful, very, very smart. Delta G is equals to 0. It simply means that the reaction is at what? At equilibrium. And what's an equilibrium reaction? It's a reaction in which, simply put in a layman's way, very, very easy. It's a reaction in which the rate of forward reaction equals to the rate of what? Backward reaction. Now, for a reaction to attain equilibrium, first thing, you have to be reversible. So a reaction in which the rate of forward reaction and rate of backward reaction are occurring at the same time, that reaction is said to be what? To be at equilibrium. So if delta G is 0, it simply means that the reaction is at what? At equilibrium. But if delta G is negative, it means that the reaction will occur spontaneously, very, very fast. Now, but if delta G is what? Is positive, it means the reaction is what? Non-spontaneous. So you have to be very careful. So if you miss any point, of course, you can get to watch the video over and over again. And please, as you watch the video, do well to share with your friends also, or refer your friend. Of course, the name of the channel is Mojaro. Now, coming back to it, you can see that we have analyzed enthalpy. So you now know what's enthalpy change or enthalpy. You know what's free energy. You know what's what? Entropy, and of course equilibrium reaction. Now the other videos I'm going to upload on this equilibrium, trying to tell you the factors that can affect the equilibrium of what? Of a system. Now what is now activation energy? You can simply put the activation energy is energy barrier. Without wasting your time, energy barrier, that is to say, is the energy that must be overcome for a reaction to occur. So it's the energy barrier of a chemical reaction. So if the activation energy is high, that means the reaction will occur slowly because you have to overcome that barrier. Now, there's one substance that can alter the activation energy of a system. Now, what's that? That is where catalysts come into play. Now, you have to listen to this analysis. Now, catalysts do affect the activation energy in the sense that if a catalyst wants to speed up the rate of reaction, it lowers the activation energy. That means it lowers the energy barrier. But if it wants to slow down the rate of a chemical reaction, it will increase the energy barrier, which is the activation energy. So they've asked in an exam, they can say, how does catalyst regulate the rate of a chemical reaction? Is by affecting the energy barrier. So you have known already what is enthalpy, which is heat content of a reaction. You have know what's free energy, which is gives free energy, energy available to perform work. Look at the formula and look at the variations. Please don't forget this. And of course, you know what is endothermic reaction and what's exothermic reaction. And of course, you know what's it called, entropy change. And you know what's an equilibrium what reaction. So this is just these few points about this question that I've shared with you this evening. Of course, you want to get to know or see other points, do well to of course subscribe and of course share with your friend. My name is Mojaro. I keep on uploading other videos for us so that we come up top in our examination. So thank you for watching. I'm out of here.